let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't.
This is so
we
awesome.
are an open culture that believes
actually
in
a big
employee
piece
success.
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed?
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am Andrew Sullivan, co-host with Mr. Johnny Rickard. How are you today, Johnny?
I'm good, man. Hanging in there. Not bad for a Wednesday, you know?
Yeah, well, for some of us anyways. Condolences, well wishes, and thoughts and all that other stuff going out to Florida folks. Getting ready to have a pretty significant little thunderstorm down there. Although it's funny because one of my the folks on my extended team is down in Miami, and he's like, "Yeah, this is just another day that ends in Y for us. Like it's like a yearly tradition when we move into fall that we get a hurricane come through." I'm like, well, okay.
You're welcome.
Yeah. Well, meanwhile, I don't know if you've kept up with the path at all. It's supposed to like cross Florida and then come up into the Carolinas, and supposed to kind of go right over, like it'll be a low by then, but it's supposed to go right over Charlotte, which is where I'll be this weekend. So yeah, it's gonna be interesting. Nothing like a couple of inches of rain.
Yeah. I'm fortunate, like where I live in San Antonio, or where I live in Texas, like we're kind of out of the way of all the stuff, right? Like out west is where the tornadoes happen. Every once in a while we'll get one. And then all the tropical depressions from the Gulf, they're dissipated by the time they get to us, right? So it's just like a decent rainstorm.
Yeah, it's funny how wildly different weather is, here just in different regions of the US. We're joined today by Adele, so product manager for OpenShift. Adele's over in Germany, so I know you can sympathize with some of the regional weather differences. But it's funny, it's been a few years ago. I've traveled out to San Francisco, and I was driving from San Francisco down to San Jose, and I'm listening to the radio as it's raining, and it's like record-breaking rain today. We've gotten 1.1 inches, and like 1.1 inches, that's like an afternoon thunderstorm here in Raleigh.
Yeah, that's flash flood weather here in Texas. So
yeah. So, well, as I said, we're joined by Adele. So Adele has been on the stream before. We talked about sandbox containers, but today we're here to talk about hosted control planes, which is often or previously known as HyperShift, which was the sort of unofficial name, the pet name, friendly name, I guess that we call it. But the official name is hosted control planes. This is something that Johnny and I have talked about a couple of times. I think we first talked about it in the What's New in 4.12. We made some references to it back when the ACM folks over on the Cloudcast, I think that's the name of their stream, they talked about it some because ACM is tied in there. At least MCE, we'll talk about that a little bit, is a part of that. So yeah, wrong Adele, Christian. Well, I'm sure this Adele would be can sing. I don't know if he is willing, nor if he sounds quite as lovely. So I won't make any assumptions. So yeah, looking forward to today's topic. We'll get there in just a moment. Adele, I don't know if you want to introduce yourself or not. I don't want to talk for you.
Yeah, hey everyone, I'm Adel Zalouk, and I'm the product manager for hosted control planes. We're going to talk also about the Dell MOs, hosted control planes, and HyperShift in a moment, but I'd leave, and I know, well, I can't sing as good. Yeah, I hope I don't have to do that anytime soon.
Well, why don't you just give us a little sample? What's not good? Why don't you just show us a little bit? Yeah,
yeah, you don't want that.
So yeah, and Adele, I think it was Peter Lauterbach. Just to call you out and maybe embarrass you a little bit. You always have the best diagrams whenever you explain these things. I don't remember the tool. I think you've told us before the tool that you use, but your diagrams of how things work together are always amazing. So.
Yeah, it's called Excalibur. For those who are interested, I get this question a lot, and I probably will. I should get a premium or something.
Get a referral fee, yeah. All right. Well, Johnny, let's talk about some top of mind topics.
Let's do it.
As I told you in chat this morning, I got pulled into a fire drill because I love fire drills. So you collected our top of mind stuff. I think I added one in there. So I'll let you please.
Yeah. So the big one, or I shouldn't say the big one, but one of the big releases this week is that ACS 3.72 came out, and so some of the highlights from that are that now they've added some RHEL 9 scanning support, as well as support for the Quake robot accounts. And then the last big one that I took out of the release notes was that now you can set up, or you can configure the timeout for non-active clusters. So if you have, say multiple clusters that you're scanning, if you have some that haven't checked in and whatever configurable parameter that you've defined, then it will remove that cluster from the scanning, and then you can just add it back. So that way you're not just sitting there spinning, waiting on something to finish. The other thing is that CodeFresh released their GitOps at Scale training. And so if you're interested in free training, or at least like learning GitOps principles from CodeFresh, they have some excellent free training. The GitOps fundamentals is pretty awesome. I plan on going through the GitOps at Scale, hopefully, this week or this weekend. But those were the two big ones I think that came out. So if you're interested in free learning, go ahead and go get your learn on.
Yeah, free is always good, right? And I think, speaking of GitOps, so one, I see Christian is in the chat. So hi hello, Mr. GitOps. But two, I think I also have an email in my inbox where the PM for the OpenShift GitOps operator, Harriet, they may be joining us here in a few weeks on the live stream. So
nice.
Not to try and steal traffic away from GitOps Guide to the Galaxy and what Hillary's got going on over there, but maybe we'll learn a thing or two. I hear GitOps
indeed.
is a thing, apparently.
Is it popular?
It depends on who you ask.
Okay, gotcha.
Christian is probably like hitting his monitor at me right now.
Good.
So the one that I added on there, so I had a conversation or an email chain with somebody inside of Red Hat earlier this week, and basically what they were asking is, and we've talked about this before, I think, Johnny. Can I let's say something happens to my cluster and I have an etcd backup. Can I deploy a new cluster and then take that etcd backup and restore it to the new cluster? And will that, effectively recover from disaster recover, disasterdly recover? I don't know. My original cluster and all the workload and all that other stuff. So it was an interesting conversation, and it's one that, again, we've had before. The end result is that nothing has really changed. What happens when you do that? etcd is the data store, right? It is the source of record for how the cluster should be configured, particularly and especially with OpenShift, right? So you think about things like machine configs, right? Machine configs have all of the rules and policies and configuration and certificates and all of these things that need to be put onto each one of those hosts. So if I deployed a whole new cluster and then restored etcd to that cluster, basically when it comes back, it's going to say everything that's configured in this cluster is wrong, and I need to go and push all of that new configuration out. So you're going to end up in this really crazy scenario where it's trying to basically rectify the differences in that configuration, and more than likely it's going to break. And by more than likely, it is guaranteed to break. You can probably fix it, but the time and effort and everything involved there would be better off just restoring the applications, right? Use GitOps, use ACM, use any one of the other tools that are available out there to just restore the applications, redeploy the applications onto the new cluster, rather than trying to, make a new one look like the old one. Catching up on chat, which is actually working in my interface today. I'm happy.
Nice.
Yeah, I know. Will it work? No, it won't. I mean, maybe, but probably not. So it was a fun conversation. etcd is, it's not something that we want to take risks with because it affects the entire cluster. So yeah, Christian, your apps are more important than your cluster. I think that's something that a lot of us, I'm an old virtualization admin, right? I love each and every one of my ESXi hosts like a child because they're all snowflakes.
Hmm.
Um, it's hard to change that mindset to where the cluster is effectively a disposable unit. And what we really care about is the configuration that's applied to that cluster, which is all in YAML files, and the applications that are deployed to that cluster, not the individual components. What's the often overused analogy? Chickens or cattle or
Yeah.
bacteria or whatever we want to call them. Whatever bugs. Every one of these, I feel like you're going to find somebody who loves that particular animal, insect, whatever, and we're going to offend them. No offense intended to anybody who loves anything. Yeah, treat your cluster like cattle. All right, so that's all I got. Please don't hesitate to ask questions at any point in time. This is one of our office hours series of live streams on Red Hat live streaming. So what that means is that we are here to answer any and all questions that you have about OpenShift. Johnny, myself, Adele, right? We are, I'll say that we're subject matter experts, but not on everything that you could possibly dream up. So if we don't know the answer, then we'll do our best to try and get the answer for you. Sometimes we can do that before the end of the stream. So a lot of times you'll see Johnny typing away, or me typing away if Johnny's talking, or that's us trying to research answers or ask the right subject matter expert. If that doesn't happen, we'll follow up. So we can follow up via social media. We can follow up via next week's stream. We can follow up in any other number of different ways. So if you would like, you can reach out to, and now I got to remember how to click my buttons here. So you can reach out to me. I'm available social media at Practical Andrew on Twitter, on Reddit, on all of the different things and places. Or you can reach me via email, andrew.sullivan@redhat.com. Particularly important for anybody who's not watching us live, feel free to reach out. We love to hear from folks. We love the chat and everything while we're doing this live, but just as importantly, just as much fun as getting those questions. It really, I won't say it brightens my day, but it makes my day interesting to hear and to learn from all the stuff that you all ask us, because literally without fail, every single time I learn something new.
Totally.
I will also throw Johnny under the bus here. So Johnny is JRockTX1 on all the various socials, etc. And Johnny, J-O-N-N-Y, at redhat.com. I will also encourage folks, if you haven't already, go ahead and join the Kubernetes Slack. So kubernetes.slack.com. And if you go there, there's an OpenShift users channel. It's a great place to meet roughly 3,500, 4,000 now of your closest friends, where we can talk about and ask about, all the different stuff that's going on with OpenShift. If there's anything that you want to know inside of there, by all means. And it's a community of more than just Johnny and I, right? So it's also a good place. Thank you for the link, Johnny.
Yep.
All right. With all of that being said, my preamble being done here. So one, I do want to be cognizant of time during our conversation here. So Adele, I know it's late in the day for you, and I think it's not even the end of your day yet. I think you said you have a meeting after this. So we're going to try and hit our top of the hour mark, at least where Adele can leave. If we're still answering questions, that's okay. But we'll let Adele quietly leave out the back door. But yeah, we want to make sure that you have plenty of time. So hosted control planes. Again, this is something that we started talking about a while ago. I say a while ago, we're talking like, a month and a half, maybe, when 4.12 was released. And the core concept here is, and I'm trying to, and I don't, thank you. So I don't want to steal your thunder, Adele, but the core concept here is effectively using one OpenShift cluster to host the control plane services as pods for other OpenShift clusters.
Right. Yeah. So that's basically the gist of it. And I'm gonna talk in details about this, but really it's the concept itself is really nothing new. We've seen that with other service providers like EKS or AKS or self-managed offerings like Gardener or Kubernetes. But we're really trying to bring that architecture into OpenShift to highlight and make it simpler for people to consume OpenShift the way they see it fit. Right. And so what we're doing is we're not innovating in the architecture itself, but we're innovating in OpenShift core itself and making it easier and faster and cheaper to run workloads on OpenShift. That's really, if I would summarize this, will be that.
Yeah, so I think there's, and please add on. So my basic understanding, I see two primary, benefits. So one, because we're not having to deploy, like, we're not using cluster API or machine API to deploy like a whole new set of VMs for a control plane. Like we can skip a pretty significant part of the new cluster instantiation process. And two, because we're not deploying those virtual machines, we can also save on resources, right? Because there's overhead associated with those, there's cost associated with those, et cetera.
Definitely, yeah. I think the main takeaway from this is really, with standalone or with OpenShift, the way we're used to deploying it, we're requiring a certain minimum number of nodes so that you can host your control plane. These are usually infrastructure EC2 or on any cloud provider. On AWS is EC2, and then you're paying for these infrastructure costs yourself. And these are usually taking a good chunk of the cluster, depending on the size of the cluster, of course. We're trying to make that simpler, and by basically bin packing control planes and utilizing on economies of scale, reusing nodes when it's required. And so we're optimizing on different aspects and reusing a lot of existing concepts that we know and love and are experienced with in Kubernetes itself, treating control planes as workloads. Yeah, so this is really, the gist of it is trying to improve usability and productivity of development and make it easier to run multiple clusters, right? Which is also an important part of what we're doing nowadays. Like people talk about multi-cluster, but we don't talk about how the cluster architecture can make things harder or simpler when you're managing clusters at scale. And that's really where we talk about hosted control planes. It's more a catalyst for that whole multi-cluster talk, to make it more affordable and scalable.
So I have a bit of maybe a strange question. So the OpenShift control plane has always been in pods, right? Whether or not anybody knew it, right? CoreOS, you deploy CoreOS, it basically instantiates, it puts kubelet in place, and then everything is a pod inside of there.
Right.
So if you don't, again, weird question, like how come it took us till 4.11, 4.12 to think of this concept of hosting control planes?
Yeah, we're already running pods, but the way we run pods is different, right? We run static pods. The static pods is basically managed by the component called the kubelet, which manages the lifecycle of workloads running on a cluster. And so with static pods, you lose some of the features. Like you can't really get deployments on there because deployments are a higher artifact, or replica sets, or all these things that live on top that manages lifecycle of things other than the kubelet doing it. You don't get that. And so what we're doing with HyperShift is like treating the control plane as really as any workload. And by doing so, we're enabling that higher layer primitive controllers to actuate and reconcile on control plane as workloads. Yeah, and as the folks on the chat saying, it trickles all the way down. There is there's no limit to the inception of the control planes, and so you could host a control plane for a cluster, then host a control plane for another cluster, then all the way down to the end.
Creating the ultimate single point of failure.
Yeah, not really, but
well, you got that, whatever that top level or bottom level, I guess, depending on your perspective, cluster, like that would cause a cascade of failure, right?
No. Not really, because when you're running things, you're running control plane as workloads, and we have to make a differentiation here. The control plane is where the API server, the kube, are hosted, but then the workloads keep running. And if I have another cluster that is hosted as workloads on that, if the control plane of that parent cluster dies, my workload is not affected. I'm still running on nodes. It's on the hot path. It's the data path, not the control path. The control path is for I want to schedule a new workload on there. I want to schedule a new control plane. That might not work till the outage or whatever happened reconciles back to normal. But yeah, that's it's going to continue living on, and we take a lot of precautions also to avoid that happening in the first place. But we can't always say that in probability. You cannot say it's 100%. I'm confident it's not going to happen. Yeah. There's always a chance, a likelihood of things happening. So let's say 95% confident that this will be mitigated the right ways, but there's always a chance for it happening. And when it happens, we're trying to cushion that with a lot of mechanisms.
Yeah. The only thing that's certain is that nothing is certain.
Yes.
So there's a couple of questions in chat. Ankit, I'm not sure if that's a question or not, but I'm going to turn it into one, which is, when deploying a cluster using a hosted control plane, do you still need a bootstrap node?
No, we don't need a bootstrap node. You have a cluster already, and since you're running the control plane as pods, HyperShift. Okay, let's back down a bit. Hosted control planes is basically the product feature, right? And then HyperShift is the project used underneath. Like we talked before about sandbox containers and kata containers, or OpenShift GitOps and Argo CD, or pipelines and Tecton. All these things are, we give you the project, Kubernetes is the project, but good luck lifecycling that, good luck securing that, good luck supporting that. And so we're removing the luck out of the equation and giving you the support through hosted control planes as a feature by offering it as a self-managed form factor of OpenShift. And so that's really the idea. But yeah, it's important to it's still OpenShift. It's not something coming up from Mars. It's still OpenShift, and we're not changing what the user sees. We're changing the architecture of things.
Yeah,
more or less.
Well, I would imagine, because the purpose of a bootstrap is effectively to be the first node that comes up, and it provides the proto control plane, the one node etcd, and the machine config server that the real control plane uses to, well, bootstrap itself and get let etcd form and get a quorum and deploy other services on top. So since we're deploying into an existing cluster, right, we're deploying as pods. Basically, we don't need to have something stand up that one node etcd so that we can then add other nodes. We just turn on 3 pods, right?
Yeah, and if something happened, okay, I think you still can hear me, but you can't see me, right?
We can hear you, but your video is frozen.
Okay, let me rejoin quick.
Let's see. Looking at a couple of other questions here. We'll get to all of these, just maybe slightly out of order. Can I run host control plane on microshift? I don't know, Christian. We'll ask that.
Yeah, that's a good one.
And it's now what did they rename microshift to, Johnny? Something edge. Yeah. I don't remember. Device edge.
I didn't even know they renamed it yet. Oh, okay, nice.
Yeah, I have a feeling.
Maybe I shouldn't say that.
I have a feeling I'm not going to be able to share my screen because whenever I do it, something happens.
Okay.
But I think, yeah, I'm thinking of trying another browser in that case to see I can do that in parallel. So let me try.
Just to quickly answer Steven's question here, can an x86 control plane manage ARM nodes? Yes. That is GA now, I believe, in 4.11.
Is that, I think the question is, in the standalone form factor, or is the question about hosted control planes?
I don't know, Stephen, if you don't mind clarifying, when you're referring to, is it like can an ARM cluster use hosted control planes to host the control plane for an x86 set of worker nodes? That was very nuanced. I feel like I've been doing a lot of these nuanced questions lately. I've been answering questions about tenant OpenShift clusters for OpenShift virtualization. And it's one of those, like, you have to be very careful with language so that you can understand which one you're talking about and which one is which. All right, well, there's 2 of you now. Uh-oh.
Some ninja cloning. Okay, yeah, and I just changed the browser in parallel just to, try to avoid that failure of sharing. And I'm just gonna try again and share my screen just to make sure. All right, screen 2.
Yeah, so Stephen clarified. So can you run a hosted control plane on an x86 cluster to manage ARM workers?
Yeah, so that's actually in the pipeline for us for host. So first of all, hosted control planes as a feature is still in tech review. We have not GA'd the feature yet, and so in the future we're looking at ARM control planes. We're looking at other types of architectures in parallel with x86, and potentially also the opposite, like the control plane being hosted on ARM workers instead of the parent cluster, and that should also work. Some reason it's not.
It's just one of those days. Apparently, I was telling y'all before we got started. So today is my oldest, his birthday. He turns 15 today, and rather than he got me a gift, which is a sinus infection, because he just went back to school. You know, he's 3 weeks into school. So
Hey, happy birthday.
yeah, I don't, I don't miss, like, COVID is awful, and I hated all the shutdowns and all that other stuff. You know, I'm sort of an outgoing person. I like to see and interact with other people, right? I don't miss the part of, isolation and all that, where I didn't get a cold or a sinus infection or anything for like 2 years.
Mhm.
It was wonderful.
Amazing.
Yeah, it looks like I'm also not able to. There's a curse of today on this. Should I try one last time?
You can either try again, or if you want to share the link with Johnny or I, one of us can share a screen.
Right, I'm going to also need it for the demo. So, but we can do it like this. And
Yeah, Dwayne, I think it's just the time of year, or for me, like, historically, every time the kids go back to school, I always get something.
Yeah.
It's so strange because I can see your screen in the preview, but in the stream window, I don't see your screen, Adele.
So are you able to see what I'm sharing on the screen?
No.
Oh, I can actually see it on YouTube. So if you go and look at YouTube and Twitch, you can see the output. So yeah, we're good. We just can't see it in the restream.
Okay, okay, strange. I didn't expect to have trouble in the stream itself. I thought the demo was going to be there.
Yeah. Well, it's unusual for Restream. Restream, being browser based, is usually pretty straightforward. So.
Yeah, one last try was the native tooling of then. My last try with Safari. And are you able to see my screen?
Yep. Well, we did.
You're seeing the wrong one, probably.
Yeah, in the preview, it looks like it's the Restream window, so we can.
Hey,
there we go. We can both see your screen, and you're still moving. So.
Yeah. For the stream, so I'm gonna share this. Just tell me. Trying to.
Yeah, I hope not. I hope that passes quickly, or I hope that that's not true. Of, they're like the whole flu season is upon us and all that, and after 2 years of almost no flu season, that it's going to be bad or anything. I hope that's not true, but
yeah, me too. What's funny is, so my daughter, she knows that if she goes to Target and gets her flu shot, that she gets like a $5 gift card. So every year around flu season time, she's like, Roger and up, ready to go, because she wants to go get her gift card so she can go do some shopping.
Her $5, yeah.
Yep. And Dwayne had a question earlier about Oh, sorry. Go ahead. Yeah, Dwayne was asking, does a hosted control plane imply more efficiency in slicing of the SDN?
More of the SDN. Each cluster gets a CNI, and so like it's not really. So do you see my screen now?
Yeah, but your audio is getting choppy. Let's maybe give up on that for the moment, and then we can answer some questions. We can have a discussion. There's a number of things that we've got in the list here that we can talk about.
Okay.
So we don't want to. I know you've only got 30 minutes, so we don't want to spend too much time.
Yeah, too bad. But anyways, what questions?
Yeah, so Dwayne was asking about SDN, and it was a question that I had as well, which is, if we have all of these, distinct control planes that are, running inside of a cluster, presumably connected to the SDN, how does that traffic get in and out of the cluster? Is it using routes that each one of those child clusters uses?
Yeah, each control plane, or was each slice out the out of the cluster, because OVN is previously using in the tech preview OpenShift OVN as the main the support recommended way to support working. And so each control plane, the control plane of, and then the management cluster, the management clusters SDN is OpenShift CNI, OpenShift SDN, all the control planes on that management cluster.
Your audio is kind of blipping in and out, Adele.
Yeah.
See.
You see Peter's thought process there, Johnny, around the flu shots. Get 20 flu shots means that you're making money.
That's right. It's a little side hustle, I mean, as long as you're willing to go get it done.
Yeah. Is it working? Is it better now?
Yeah, there we go. That sounds good.
Okay. It's not really. So I switched like 3 browser just now, and Safari is probably the one that was the worst. I'm testing browser for you in case next time. Yeah. So basically, what we're saying is, that management cluster, or that hosting service cluster, what we call in the product, is what is sharing the SDN with all the control planes. But each cluster, each control plane, along with its workers, have a dedicated cluster, and each I could deploy a different CNI. I could have hosted cluster number 1 on OpenShift SDN, theoretically speaking, because as I said, OVN is a supported one. But you can have any of the third parties like Calico or whatever on your hosted cluster while your control planes are running and using the management or the hosting cluster's SDN. And so you're kind of slicing each cluster with its own networking, but you're sharing the networking with the underlying cluster. And that's usually for the end user is more or less they don't know about that. You as an SRE or you as a cluster service provider, you are the one managing the SDN of the parent cluster. Your end users, your developers, your cluster admins are the ones looking at the other, the dedicated SDN, and not really managing or caring about it. And maybe just to mention, because I mentioned a lot of words about personas, just let me clarify the personas and the terminologies a bit. We have 4 personas when we talk about hosted control planes. I was going to show that on the slides, but excuse me. We have the cluster service provider. This is usually the persona or the role that you assume when you're providing control planes as a service or hosted control planes. And that's basically saying, I have control over the infrastructure. I have control over where I store my credentials for that cluster. So I'm providing that infrastructure or grounding for the hosted control planes. Then there's the cluster service consumer, and that's basically another persona that is requesting, like has access to request control planes. And then the fourth cluster is the cluster instance admin and the cluster instance developer. These are what we were used to. When I open an OpenShift console, I'm going to see on the left side upwards, I'm going to see either administrator or developers. And this doesn't change. From an end user perspective, this is what you're going to see. From a cluster service consumer perspective or a cluster service provider perspective, you're going to have access to things like Advanced Cluster Manager or the multi-cluster engine to create these hosted control planes yourself, or through the API, through the CLI, through Ansible automation, through any form of interface possible today that we provide with OpenShift.
So you mentioned MCE, multi-cluster engine, which we touched on back when Jimmy Alvarez from the ACM team was on. So hosted control planes uses MCE to deploy the clusters. ACM also uses MCE to deploy clusters, but you don't require ACM to do hosted control planes.
Yes, and I think this is really something that confuses a lot of folks here. MCE, the multi-cluster engine, is and it used to call it's still called the backplane operator. The backplane operator for what? For advanced cluster management. It's the backplane for managing the cluster lifecycle. Because what we provide with ACM is a whole bunch of features, a lot of features that are really useful, but some folks see it as too much when they're starting out, and they just want to manage the life cycle of their clusters. And so what we've done, we basically forked out that functionality, created an operator that dedicates itself, its whole livelihood, to just managing life cycles of cluster, and that is available with the OCP entitlement. So you get OCP, you have an OCP subscription, you go to the operator hub, you install the multi-cluster engine, you have a console view, completely new. And again, I wanted to show that, but I don't have access. It completely new, and you're going to see a lot of like the cluster, multi-cluster pane, and you're going to be able to create credentials for cloud providers. You're going to be able to lifecycle clusters on AWS, on all the cloud providers that we support, on bare metal, HyperShift, single node, all these. So you have the cluster lifecycle power in your hands with MCE. When you're ready to go further, and you will need to at some point in your in the life cycle of your OpenShift deployment, as you grow and you deploy more at scale, adopt key ops, or you get more workloads, you're going to need application lifecycle. You're going to need vulnerability management. You're going to need policy management. You're going to need central observability, and all these things are nicely packed up and provided in Advanced Cluster Manager, which you need in a separate. It's not coming with the OCP entitlement. You need a separate entitlement to get Advanced Cluster Management. But again, MCE, when you get ACM, you get MCE. But when you get MCE, you don't have to get ACM, right? And that's really the important part that we need to understand. MCE is just the cluster lifecycle bit of ACM, if you want to refer to this way. If you want to forget about ACM for now, MCE is just doing multi-cluster lifecycle. And HyperShift, or hosted control plane, the features is shipped. When you install MCE on your cluster, by default, you're going to get HyperShift. You're going to get hosted control planes. So the reason we're doing that is we strongly believe that hosted control planes strongly simplifies how you do multi-cluster, and through the benefits of like it optimizes for cost, because I'm hosting multiple control planes on reusing the nodes. It optimizes for provisioning time. I can provision a cluster in less than 10 minutes end to end. And it encourages also the separation of concerns, because I now have a defined interface between my management, right, my control plane, where I manage the control plane. So these, as I said, there are like 4 personas versus the 2 personas that we're used to in OpenShift, and the other 2 personas, the cluster instance admin and the developers, are usually like the instance admin can see your API server. If I do HyperShift now and I kubectl get all pods, I'm not seeing an API server. I'm not seeing a control plane pod. I'm just seeing workloads and just system components that run as daemon sets on, because these are needed on the nodes themselves. But as a developer, we still have that gating as well. So this is really the difference here.
So there's a couple of things that I want to poke at there. So one, Christian is thinking the same way that I am of, does MCE replace Hive? Or is it just a new version of Hive, or how do those two things fit together?
No, I think, yeah. So think of OpenShift as, a car type, right? And the dealer you go to the dealer, you get a lot of car types depending on, I want to drive fast, I want to drive slow, I want to drive safe, you get a Volvo, I want to drive fast, you get a Ferrari. And so depending on your use case, right, we're going to, give you that option to provision clusters that match this requirement that you just defined. And so MCE is your car dealer. You go there, and then MCE ships with it. It has Hive. It has the assisted installer for quick, ISO initiation, and you get bare metal just in less than in minutes. And then you get Hypershift. Hypershift is bundled across MCE. It's a different type of car, but it's still from the same car dealer. So all these Hive, assisted installer, and Hypershift and ZTP, they're all peers, right? That are, or cars, different car types that are provided.
So they're like plugins, basically. So Hive is still good for doing, IPI installations across all the various infrastructures. MCE or Hypershift for doing these, hosted control planes, or assisted installer when you want to use that for bare metal clusters or UPI clusters, that type of stuff. So no, that makes sense. That's the first time that it's been described to me like that, and that's helpful. I wondered if the analogy between like cockpit and satellite and Ansible automation platform is appropriate. Of satellite I can use to deploy RHEL machines, and I can connect those into cockpit running on one of those machines, and I can manage individual machines from a single interface. But I can also use Ansible automation platform to manage them as a group. Well, if we turn that into now OpenShift terms, I have, my OpenShift cluster, my MCE cluster, where I have the ability to manage individual clusters. And then I have MCE behind the scenes, like satellite, that's being able to do provisioning and lifecycle management. And then I have ACM that's able to do the broader range, the more extended set of management capabilities.
Right. And these are all, they don't just replace one another or think of it as alternatives. Like when you mention Ansible, like we today have Ansible pre-hooks and post-hooks for each cluster creation process. We cannot automate or know and predict what you want to automate in your environment. And so we need to provide hooks for you to do so the way you see fit. And Ansible did a great job. And I think it's still the biggest open source project. And so it does a great job of automating out of scope of Cube APIs, the things that you don't want to move to Cube. But at the same time, you have these integrations within the cluster creation process itself. So you're writing your own playbook. You have satellite to manage those, and then you have MCE, which gives you a way of managing machines and clusters. And then each managed in a different way, worker pools, node pools, and we have the machine controller manager, cluster API for managing machines. These are all things that can be managed by Cube that you don't have to delegate to automation like Ansible. And then you have ACM on top, which does a great job in application lifecycle policies, Kubernetes, OPA, Gatekeeper. These are tools that we can use to realize policies. I want to define a policy across a set of clusters. I have a cluster set. They're like siblings, and so they have some common patterns that I want to do an action, a group action against. And so ACM does the multi-cluster management part. MCE gives you the means to lifecycle cluster with your favorite, depending on your favorite use case. Hypershift provides you with the productivity to foster cluster creation with the cost effectiveness. You can host clusters cheaper and with stronger separation of concerns, depending on if you want to do network segmentation. Some customers care a lot about separating management and control plane. If you want to use standalone OpenShift, you care a lot about resilience. You have time-sensitive workloads where you're running on the edge. We have single node also coupled with MCE. So it's a layered thing that you have to think about, not just like one replaces the other.
Yeah. So our Hope 9 has a question here about, what planning do you need to take into account when standing up the initial cluster or the cluster that's hosting those control planes? For example, does the cluster network need to be sized large enough both from, I think, an SDN as well as from like memory, CPU, and all of that. Since from memory. So you're saying you recall our Hope 9. Yeah, so I think historically cluster network is immutable after deployment, the size of it. So
yeah, and so for the planning purposes, I think it usually makes less sense to, let's say, have a cluster for your management cluster was one node, right? Because then you're really just not getting any benefits when you were deploying hosted control planes. Because hosted control planes, the minimum is usually 3 nodes, and then I can host more than just one control plane on these 3 nodes. I can reuse these 3 nodes to host 9 or 16 clusters versus, what we have today is I'm using the 3 nodes for the masters and then number of workers. So you really get benefits at scale when you have more workers on your management clusters, because then you can bin pack on these workers, right? And these workers usually have a fixed cost. Of course, that changes as you grow, but then again, they get flattened out when you grow your management cluster. So the more nodes you have in the cluster, the more you can scale your control planes and host more control planes even on that. In terms of networking, nothing is business as usual, as you said, and it's usually immutable to change things, but you still can create services. You have network observability, you have all the nice features that we provide you with OpenShift proper without really changing anything. And that's the beauty of it, because I can reuse all of these features that we provide there to host control planes and monitor and log control planes.
Yeah, so the end result is effectively it's still a standard planning exercise. I don't know if maybe somewhere we have like each cluster is expected to use this many pods or something like that. Each hosted control plane is expected to use this many pods to help with that planning around, okay, well, I want to have 250 pods max per worker node in the hosted control plane cluster. How do I math out my cluster size, that type of stuff.
Yeah. So what we're going to tell you, hey, you have 3 nodes, M5X large, let's say in AWS, these 3 nodes, you're able to host 9 control planes safely and then we've used our data inside Red Hat to really measure, what's best for that in the future, because it's all workloads. We have the cluster autoscaler, you can scale as needed. We're even thinking about, but that's a lot of calculation, vertical pod autoscaling, horizontal pod autoscaling for the control planes. So I could scale my control planes the same way I'm scaling workloads and meld that with cluster autoscaling capabilities for the nodes themselves. So that's really a powerful feature to let you, delegate the thinking of how I manage and scale my cluster to cube tooling that exists today.
Yeah. So Stephen's question, will we be able to migrate existing clusters to a hosted control plane? So a way, basically, eventually be able to remove for an existing cluster those 3 control plane nodes?
Yeah, the migration path to move the control plane of an existing node onto a hosted control plane. So I'm not sure I'm getting that question, because the control plane is already hosted when you're using HyperShift or hosted control planes, the feature, or maybe he means,
well, for an existing cluster. So I've got an OpenShift cluster today. I deploy a new cluster for hosted control planes. Can I migrate my first cluster, my original cluster, so that it now has a hosted control plane, or do I have to deploy a whole new cluster and then migrate the workload over?
Yeah, so we're doing that greenfield. Migrating from standalone to HyperShift or hosted control plane is not going to be supported for a lot of reasons. I think it's long for this discussion, but it's the only way that we're going to do it. It's greenfield. So if you want to start hosted control plane clusters, you need to start a new cluster and host or migrate your workload. So it becomes a workload migration a problem versus a control plane migration problem, right? Use the migration toolkit for any of the tooling we offer you to migrate your control planes and host them onto a hosted cluster. Just that.
And then another question here from our Hope 9. What overhead is associated with each cluster? Nodes per cluster, is that a better reference? And I think the answer here is there isn't so much overhead so much as just each service of the control plane consumes a certain amount of resources. So if you have an OpenShift cluster today and it's running approximately the same workload that you would expect if it's a cluster deployed with hosted control planes, the amount of resources used on those control plane nodes for those control plane pods would be the same. you're regaining any resources that are unused on those control plane nodes, as well as any resources that are used by the underlying core OS, right? Because effectively it's just the pods. The pods are hosted somewhere else. All of the other resources are.
Yeah, and I have so for an idle cluster that I have now, it's like looking just to give you an idea. Also, we have data for the non-idle, but for the idle cluster, I'm using the control plane is using 4 gigs of memory and 300 milli core of CPU. That will grow depending on the size of workloads, but the gross is not huge. Like it can grow by 15 or 20%. But again, that's for the 75th percentile of our data. As the more data we get, the more we understand how people are using their clusters at scale, and that will help us also size better in that. But that should give a sense of how big is a control plane from a hosting control plane perspective. That was that question.
I would imagine it also makes cluster scaling easier. So for that cluster with the hosted control plane, now the control plane resources are decoupled from the node. So I can, on my hosted control plane cluster, which is there a name for that? Is it like the host cluster?
Yeah. I have that starter kit, but we call the hosting, the management cluster, the hosting service cluster. We call the cluster where you host your workloads the hosted cluster.
Okay.
And so the hosting service is HyperShift, or the thing that gives you cluster. The hosting service cluster is the cluster that you host or you deploy your hosting service, and the hosted cluster is where you deploy your workloads.
Okay.
To.
So worker nodes in the hosting service cluster can be added and removed in order to add capacity for those hosted control planes.
Yes.
And it's no longer, we get asked fairly regularly, how do I change the size of my control plane nodes? Well, now you don't have to. You add more worker nodes of whatever size are needed, and effectively the pods will, eventually land on there.
Yeah, and to add to that, I think that probably is usually a follow-up question is, okay, so I keep adding. There's usually a limit, like everything in life. In Cube, I hit my etcd, like my parent etcd limit, or you can always add more management clusters, and in the future we're going to do that automatically. So advanced cluster management, it's advanced, and so hopefully it's advanced to do that as well. And so that's what we're thinking about. Like we're thinking about the management clusters themselves as the same way you think about pods or workloads, like you're hosting on a kubelet. And I think that's also something that is common in these type of architectures where the control planes are hosted remotely. And and we get the benefit of like, hey, it's not completely new. We're already using existing concepts to do that, and you get OpenShift using these concepts.
So in the last couple of minutes that we have you, I want to touch on something that I think will be very important, and that is, how do we protect those hosted control planes? What happens if something happens to the hosting service cluster?
Yeah, so by default, with the API we provide HyperShift, we have 2 options, right? The first option is highly available control planes, and the second option is, we call it single replica. And single replica, we will never recommend that in production. It's if you're testing or developing, that basically says the API server, your etcd, your whole control plane is just going to be 1 replica. It's still a replica of a deployment, so if it fails, it's going to be reconciled back. But if you want to really, have highly available clusters, we provide that option through our APIs. And basically, you just set that feature, and it's going to deploy with anti-affinities across all the zones of the parent cluster. So the parent cluster usually resides on multiple zones for highly available in regions, right? If you think about AWS, EU Central 1, then you're going to have 1A, 1B, 1C. Each region, each zone is going to have a replica of the control plane, and so you're already safe when it comes to cross-zone availability. At the same time, we have a backup and restore feature today. In Tech Review, you can do that manually, so you can go and back up features, but it's still a PVC on, let's say, an AWS. It's backup. If the whole cluster fails, you can, and you start again, it's going to start from where it stopped, basically, and nothing will happen. And then finally, you have we were working on a migration feature, so I can migrate a control plane of an existing hosted control plane cluster from one cluster in one zone to another cluster in another zone. That can also be useful in case I reach capacity in that cluster, or mainly for high availability and disaster recovery. So there's a lot of ways here that we are thinking about making disaster recovery, and as we grow, we're even going to be more creative in doing so, automating many of the steps to do that.
That last one is interesting, right? Because
Mm-hmm.
since the control plane functions are decoupled from the underlying operating system and the management of those nodes, it means that it's just a DNS entry, right? All of the worker nodes just look for API.clustername and API int, and they don't care where it's at.
Exactly.
That's really cool.
Yeah, exactly. And each cluster gets its own etcd. It's not shared, right? Like in the normal way, like we have in standalone cluster namespaces, and your workloads from different tenants share the same etcd. No, each cluster, each control plane as a workload has their own etcd instances for quorum, and that's completely independent from the others.
And I think another thing that's a little different there is those etcds use PVCs for their storage, right? Traditionally, with control plane nodes, etcd uses the underlying operating system disk, but now they're using PVCs.
They're using PVCs. So yeah, you can define, you can deploy, for example, something like ODF and have PVCs that become the backend for the PVCs, or you can use EC2, GP3 storage, or you have, depending on the cloud provider used. There's flexibility in doing so.
Awesome. Peter has an interesting question here. Not that they're not all interesting or good questions. Is the version of the hosted clusters, does it have to be the same as the hosting service cluster, or can you have different versions of OpenShift in there?
You can, but there's a limit to it. So you can have, I think, to n+2 and n-2 versions of OpenShift on it, but it's not open-ended, right?
Okay.
So there's a limit to what versions you can host on a control plane. Usually Cube is friendly with -2s, and so if I deploy a workload that calls out to APIs of a cluster that is too old or too new, then it's not going to work. So we have to guardrail that with versions.
That's awesome. Like, just think about like all the stuff that we've been going through in the last year or so, right, Andrew? Like, you think about the 4.9 stuff with the API deprecations, and that's going to be a continuous thing that we go through. But then, like, even with 4.12 coming up, right, with the pod security policy and going to pod security admission, having something like that where you can spin this cluster up, like, all right, let me go just see, am I gonna get shot right in the foot as soon as I deploy to 4.12, or am I good to go? But having that capability to spin something up quickly and then test it, that's super rad.
Yeah.
So Peter, I see Peter asking about 3.11. No, Peter.
All right. Well, Adele, I know you've only got a minute left, so Johnny and I will close out the stream. Thank you so much for joining us. We really appreciate it. We'll follow up with any questions that come up.
Maybe for the folks who are just getting to know HyperShift. So I have this link tree thingy that I combined all the links in case we need to refer to it. So let me grab that, and then I can be off on my way. Let's just send it in the chat.
Yeah, we'll get that posted.
Yeah. So basically, this is like, let's say, think of it as the starter kit. Send it on the chat. Just tell me if you have access or not. Here's the second link should work. But that should point you to a page that has, let's say, good starting points for you if you're just hearing about HyperShift or you want to understand a bit more about it.
Okay. Yeah, so I posted that link in there so that shows up on all the different services from whatever account we use for those. So if you post into YouTube doesn't replicate links across all the others for whatever reason.
Yeah.
But, again, Adele, thank you so much. For our audience, Johnny and I will stick around for a few more minutes, answer any other questions that come up. We'll also talk a little bit about what's coming up in the following weeks. But yeah, don't hesitate if you have any questions, both now as well as in the future if you're watching this recorded. reach out to Johnny or I, and we'll follow up with Adele and get any of those questions answered. And Adele, hopefully we'll be able to bring you back on to do a demo.
Yeah,
and all that stuff.
Too bad I had a nice demo for you.
It's the best one ever, right? Yeah.
All right. Yeah. So good luck and thanks everyone. Have a great day.
Thank you very much.
Bye.
Thank you, Adele.
Bye.
All right. So to our audience, so first, thank you everybody. We really appreciate you sticking around. So we're happy to answer any questions that you happen to have. Johnny, I don't know if you've been keeping track of chat. I think we hit on most of them.
Yeah, I think we got them all.
Okay. So yeah, if you have any other last minute questions, anything that you didn't get asked, please feel free to submit those into chat, and we'll do our best to answer them. I know a little bit about hypershifts or hosted control planes, but Adele and the rest of the team, they're definitely the experts. There's a lot of really cool stuff that's coming up there. One of the things that I learned about it is that it doesn't use machine API. So it uses HyperShift uses cluster API in order to deploy and manage those worker nodes. So I thought that was a really cool change and something that I think some people will find to be important. Keeping up with that stuff. I also thought it was interesting, as Peter pointed out. I think it was Peter who asked the question about different versions. It's cool that we can have a bunch of different versions of control planes all hosted inside of that one cluster.
Yeah.
I do have, and I'm looking at my notes here, or I'm bringing up the notes here. There are some still questions in my mind that I hope that we can help to address, right? So the biggest one I still think is, providing examples, reassurance, concrete evidence that if something happens to that hosted service cluster, it's not, it's recoverable. It's not something that is going to suddenly lead to, dozens or hundreds of other clusters suddenly going down and becoming inoperable. I know engineering, like that was the first thing that came up with them. And I know that they've done a lot of work across a lot of different areas to help with that. So I'm looking forward, as we get closer to GA, being able to really see what that looks like and how that is mitigated.
Yeah, I'm curious, anxious, excited, all of the above, to see kind of like how security perspectives and postures kind of change with this, right? Because, a lot of times with the scanning, like the issues are the static pods, like they have issues with that. They don't want anything in it.
Yeah.
They don't want anything on the file system, essentially. But to have like the one hosted cluster just be the only spot that has that stuff, and then have your HyperShift clusters, kind of sprawled out, so you can have your customers like, hey, I've got this group of people locked into this cluster via this control plane and all that. I'm curious to see how that's going to pan out, because it seems like it makes things a lot easier. You know what I mean? It logically it makes things easier, but we'll see.
Yeah, I mean, at the same time, it's the same paradigm that we see with like vCenter, right?
Mm-hmm.
Or the management network for hypervisor hosts. Of that is the quote unquote keys to the kingdom. If somebody compromises that, they now have access to all these other things. So
right.
I suspect that a lot of our high security customers are going to want things like, I want to use a storage provision or CSI driver that can do, per PVC volume encryption at the host level.
Mm-hmm.
So that way, like, there's no, even if there is an escape, it's still encrypted and it's using keys that are specific to that particular instance. And, in addition to etcd encryption itself, right? Storage level encryption and all that. So there's a lot of outstanding questions. And like I said, this is something that I think as administrators, it's interesting to us because, one, it saves on resources, let's face it, CPU, memory, right? All of that other stuff isn't free. So anytime that we can save on those resources, especially if it's being hosted in like VMware or something, I can reduce, the control plane overhead, right? I'm getting rid of those 3 extra VMs, save costs, all that other stuff. I think that's going to be an important factor and something that drives interest and adoption from us.
Yeah, for sure. I can think of like a few different things that I could use. The multi-version thing is awesome to me. I mean, that feature out of the box is like, that's a home run, because the number of things that you can do. Let me test the new features that are coming out. Are they going to break things?
10-minute provisioning times, right? And
yeah,
I think I'd have to go back and look. I think it's just a YAML object, right? Just like with Hive, I create a YAML object and HyperShift deploys the cluster. So yeah, super easy testing for upgrades and stuff like that.
And to be able to like, if you're a developer, right, to run a pipeline that literally spins up a cluster, it goes and does its thing, it does all the tests, you can do all your unit testing and all that stuff, and then just kill it all, and it doesn't matter. You know what I mean? That's it's awesome.
Yeah. Oh yeah. That's it. Yeah, that's a really good point. With API deprecations, Kubernetes 1.25 has another set of API removals.
Yep.
So that'll be OpenShift 4.12 maybe.
12. Yep.
Yeah. So, I prepare for us to have another set of streams, right, about APIs being deprecated and how to detect and handle that. Christian, people were doing that with Kind.
Yeah, exactly.
Partners, they were using OpenShift local or code ready containers for their CI system. They would write an operator, and then they would have their CI system go and deploy code ready containers, and they would deploy it in there, and that's where they ran their tests. And that has its own set of both benefits as well as or pros and cons, benefits and detriments. I feel like this is a much easier way, because spinning up code ready containers means that I'm probably having to use, not that this is necessarily a bad thing, but something like Ansible, right? I reach out and I call an Ansible playbook and it spins up code ready containers, whereas now it's all Kubernetes native. It's a YAML file, and I have a shiny new cluster that can be as small as one node, because the control plane is hosted on hosted somewhere else, and it's a full cluster just with one node.
And the other part too, right, is you get all of the observability that comes with that. So you get all the metrics funneled up and everything. And if you're using ACM, then you have the observatorium and all. I mean, there's just all the crazy stuff that you can do, right? That'll be at your fingertips now, and within 10 minutes, which is super rad.
Yeah, I don't know why it never occurred to me before that, like, from the worker node's perspective, the control plane is just an API endpoint, right? It's just a DNS entry. It's all the, with OpenShift, it's all the stuff that we add on top. So think machine config operator, that make it so that we have to have this very positive, very hands-on control over those things. But if you decouple that, if there's no need to manage a machine underneath the control plane, it goes back to being just an API. So anyways, lots of exciting stuff there. This was one that I was looking forward to. We pushed it out by like 2 months or something.
Yeah,
because we were originally going to have them on a while ago, and then Adele said, "Wait, we want to let's let things mature a little more. Let's let things, so we can get a better idea of what it's really going to look like and talk about that."
Yeah, I think we're going to have them on at the beginning of the summer, and then to your point, push it out. I think the other part of it too is that just I lost my train of thought mid thought. I've just lost it. I'm sorry.
How dare you?
No, you were just saying something.
Come on, I'm the one all hopped up on cold medicine over here.
I really have no excuse. I really have zero excuse. No, I think it's going to be awesome, man. I think that, just going back and thinking about some of my customers that were doing almost not quite a service provider, but that's essentially, hey, I've got devs that want to come in, they want to run AI workloads against like a cluster or certain nodes, just to be able to like rapidly spin that up. I'm so excited for it. Like, I think it's going to be great.
Yeah, I think we'll have to, for administrators, right? There'll definitely need to be some things that we're aware of. So let's say that my hosted service cluster is hosted in VMware, and I'm using the VMware CSI provisioner for all of those etcd volumes. Now I'm concentrating etcd and all of its requirements for multiple clusters into a single data store, or potentially into a single data store. So you would have to be very conscious and you'd want to keep an eye on that underlying data store and make sure we're not overloading it. Same thing even if you're using an external storage provider, right? There's making sure that you're appropriately distributing that workload, because etcd is finicky with latency.
It'd be cool to do a couple like different walkthroughs, like, hey, here's some variations of using this with this config and VMware and bare metal and AWS and that, you know what I mean? It'd be kind of cool to see like the different reference architectures get kind of put in place.
Agreed. So I brought up my screen here because I wanted to show, so if you go to youtube.com/OpenShift, so we've been trying to be better about posting upcoming episodes in here. So you can see next week we'll be talking about pod auto scaling. We're going to have a whole crowd of people that are joining us. Oh, look, I haven't liked this. Oh, wait, I got to sign in to do it. That's why. So we'll have a whole crowd of people joining us next week. I think there's 4 guests, Johnny.
Yes.
Yeah, so lots of stuff that's happening with pod auto scaling, ranging from the alternative recommender to Kita, which is the Kubernetes. What is it? Kita.io, I think.
I believe that's it. Yeah.
Like I've done this before. Kita.sh. So event-driven auto scaling, all of that other stuff. So the serverless folks will be joining us to talk about event-driven scaling for serverless deployments and all that. So that's going to be an exciting one. And if we look back over here to the other one, composable OpenShift. So this one's really cool. Composable OpenShift allows you to determine which of the cluster version operators you want to include or not, as the case may be. So just for reference, right, if we look at here, my sample cluster here, I do an OC get CO, I've got all of these operators that are inside of here, right? So composable OpenShift will allow us to exclude certain operators from here. So, I don't need OpenShift samples. Well, great. It just never gets deployed. I don't even have to worry about it or think about it inside of there. So composable is something that I think is going to be really cool. It'll allow us to reduce the footprint of an initial deployment and all that. For things like single node OpenShift, where every CPU cycle, every byte of RAM is important, contribute to that.
Yeah.
So so that'll be in 2 weeks. I think the week after that, I'm not positive. The week after that, which is the week of KubeCon, we will not be streaming that week. There is an absolutely massive list of sessions that Red Hat folks are participating in that I believe that they will be posting onto cloud.redhat.com/blog. So if you're interested in any of that, be sure to check it out. And then we're out in November. Kind of scary. It's funny. My daughter asked me, she's like, "Oh, what do you think I should be for Halloween?" I'm like, "Halloween, isn't it like May?"
I know, man.
So, already kids thinking ahead because candy,
Yeah. Priorities.
All right. Well, so audience, thank you so much for joining us today. Really appreciate all the questions, all the chat that you've had, as always. Y'all are amazing, and one of the big reasons why Johnny and I are here. If you're not watching us live, don't let that stop you from participating in the conversation. Like we said at the start, feel free to reach out to us. So you can reach me at andrew.sullivan.redhat.com, at redhat.com. Or Practical Andrew. So again, all the social medias, all the different places, Slack and all that other stuff. You can reach Johnny at jrocktx1 or johnny@redhat.com. And again, we love hearing from you all. What was the one that we answered this morning, Johnny? You replied back.
Yeah, that was about garbage collection.
That's right. Yeah, garbage collection and detecting memory leaks.
Yep.
Pods and stuff like that. So. All right. Well, that's all I got. I got nothing. I'll leave you with last words, Johnny.
Yeah. Thanks to everybody for all the questions. The chat today was awesome. I mean, it's always awesome, but today was, the back and forth is great. I'm glad we had Adele on. Hopefully we can get him on again because he's always got good stuff. So I'm looking forward to Hypershift and Composable and just all the things that are coming up, because I think that it's gonna be awesome for any of the OpenShift nerds that are doing this on a daily. Like, I think it's gonna be awesome.
Hypershift and KCP. As soon as we can start talking about those two together, showing those two together, that's gonna be amazing. I cannot wait till we can start showing those two things together. KCP, if you're not familiar with it, just go and look in the OpenShift GitHub directory, search for KCP. It's going to be interesting.
Yeah, it's going to be awesome. So, but other than that, I'm good to go, man. Ready for the weekend.
All right. Well, thank you again, audience. Have a great rest of your week. Stay safe, especially anybody who's in the path of Hurricane Ian and any other global events that are going on. So, thank you.